Good day, in this video I'll present our laboratory experiment on subsystem integration, focusing on how two independent components communicate using the data integration model. I will explain the concept, demonstrate the working system, and reflect on integration challenges and real-world relevance. Subsystem integration is the process of allowing separate systems to communicate and work together without tightly coupling their internal logic. Each system has specific responsibility, and integration defines how they exchange information. Now, in this experiment, we have two subsystems. Subsystem A is the data provider. It is implemented as a JSON file named data.json. This subsystem stores structured tasks, information such as task ID, title, assigned team, priority, status, deadline, and progress. Who do you think you are? Subsystem A focuses only on maintaining data and does not handle any presentation or display logic. Now in the subsystem B, it is the consumer. It is implemented using HTML. This subsystem retrieves the data from subsystem A, processes it, and dynamically displays it in a user interface. Subsystem B does not store any data permanently. Now, the chosen integration model is data integration. This model was selected because subsystem B directly consumes structured data from subsystem A without calling its function or embedding its interface. Communication happens purely through data exchange using JSON, which ensure loose coupling and flexibility. First, I will show subsystem A, which is the JSON file. This file contains multiple task records. Each object represents a task with fields such as task ID, title, assigned team, priority status, deadline, and progress. This file serves as the single source of truth for the system. Next, I will show subsystem B, which is the HTML interface. Inside the script section, JavaScript uses the fetch function to retrieve the JSON file. The data is then parsed and looped to dynamically create task cards. Now, when the page is loaded in the browser, each task from the JSON file is displayed as a card. Information such as a title, assigned team, priority, deadline status, and progress are shown. The task status is visually distinguished using different colors. Now, to summarize the integration flow, subsystem B requests data from subsystem A, transforms it into visual components, and displays it into the user. No direct logic or function calls are shared between the subsystems. One major challenge is that it involves transforming raw data into a user-friendly layout. The JSON data is flat, but The UI requires grouping and visual structure, which require transformation logic, similar to ETL process or the extract, transform, and load. Now, this experiment reflects real-world integration scenarios commonly found in school systems, project management tools, financial software, and HR platforms. In these systems, data is often produced by one service and consumed by another through APIs or data feeds. Now, in conclusion, this laboratory experiment demonstrates how two independent subsystems can successfully communicate using data integration. The project highlights real-world integration challenges and how structured data enables flexible and scalable system design. Thank you.